All right, today we're going to look at 10.5 day 2. So hopefully you guys were able to get through the homework yesterday. Again, quite a few people emailed, which is great. Continue to do that if you find yourself having trouble. And again, as we keep doing this today and tomorrow, you'll get it down a little bit better. Today we have one new concept and we're only going to do one example. That'll make this a little bit quicker than yesterday. I know yesterday went a little bit long. And then when we do day 3, we have kind of one concept to look at, so it won't take as long. I'm basically trying to give you 2 more days to get some practice with this stuff. All right, so 10.5 day 2. So we looked at yesterday the steps, and hopefully you know them. If not, take a second, see if you can't run through them. Think about what is step number 1 when I'm trying to eliminate the xy term. Do I remember what that is? Do I remember it's cotangent of 2 theta is equal to a minus c over b? Do I remember the second step is to write out the substitutions? Do I remember the equations are x equals x prime times cosine of theta minus y prime times the sine of theta, and y is equal to x prime times the sine of theta plus y prime times the cosine of theta? And if you can't do it yet, that's something by the time you come back for 10.5 day 3 you should have down. You want to have those 2 down. And then do I know to plug in the substitutions and do all the algebra from there? But usually the first 2 steps are the hard part. If you can get through the first 2, then you can do the rest. All right, when we wrote down the steps yesterday, step 1, we said find the angle of rotation. We might use a unit circle or we might draw a right triangle. That's what we're going to do today. So the main topic for this is using a right triangle for step 1 in terms of finding the angle of rotation. So let's say that we want to find the angle of rotation or the substitutions for the equation that looks like 8x squared minus 12xy plus 3y squared plus the rest of it doesn't matter for what we're going to do for this. So I'll give you a second to write that out. So when I look at the problem, I see the xy term and I say to myself, okay, I got to eliminate the xy term, so I've got to find the angle of rotation. So step 1, I'm still going to do the cotangent of 2 theta. It's going to be a minus c, so it's going to be 8 minus 3, which is 5, divided by b, which is negative 12. So the cotangent of 2 theta is equal to 5 over negative 12. And I don't know that on the unit circle. So I know for this particular one, I'm not dealing with the unit circle, I'm dealing with a right triangle. So how do I do this? Because, like I said, you wouldn't have a calculator for this, so I've got to make sure that I can figure out what the angle of rotation is. So here's what we're going to do. This is something that you're going to need to make an important note on. This is one of those small details. If you ever do the cotangent of 2 theta and you get a negative number, just like we have, you notice that when I did this, clearly the 12 is the negative number. And since this is cotangent, it's x over y, clearly the y value is the negative number. However, you always make the x value the negative number, even if the y value is actually the negative number. And the reason, without going into a lot of details, when we rotate, we're going to rotate a positive direction, so like this. We're not going to rotate in a negative direction. Could we? Yes, we're not going to. If you try to do it with a negative direction, the substitutions, the xy terms, they won't end up canceling. So this is very important. Remember yesterday we did all that work and I said if the xy terms don't cancel, you got to go back and find your mistake. That is one possible mistake, that you didn't put the negative on the 5, you put it on the 12. So I've got the cotangent of 2 theta is equal to negative 5/12, and then what I'm going to do is this. I don't have that on my calculator, cotangent, so I'm going to change it to tangent of 2 theta, which just means if I do the reciprocal on the left side, I do the reciprocal on the right side. And I'm going to use my calculator. And I know you're probably saying, you just got done saying a couple seconds ago we can't use our calculator. You're right. I'm going to show you how we would do this when we get to the graphing part. I don't actually need the actual angle of rotation to do this. But what I would do is I would do this. I would take my calculator out. I got to make sure it's in degrees again, and I know mine is. So I'm going to type in the tangent inverse of negative 12/5. And then I recognize when I get that negative 67 degrees that we're not rotating in a negative direction, we're rotating in a positive direction. So I need to add 180. It's kind of like the inclination of a line. But that's not my angle of rotation because 2 theta is equal to that. So 2 theta is equal to 112 degrees. So of course I'm going to divide by 2. And 56.3, that's my actual angle of rotation. And you can see I have written here, this is only used for the graph. Other than for graphing purposes, I don't need that 56.3 degrees. So let's say I gave you this problem and I wasn't asking you to graph it. Then what I would do is I would do this. I would say, okay, I've got this. Great. Next thing I need is substitutions. I'm not actually going to find the actual angle of rotations. So I go to, how do I find the substitutions then if I don't know what theta is? Well, that's where you're going to draw a right triangle. Now, I've said this many times, draw your right triangle accurately. It should either be the first quadrant or the second quadrant, because remember, we're making the x value negative. So if you're drawing your triangle like this and then you're labeling with a -5, it's fine. It just doesn't look right. Try to make it look like it's actually in the second quadrant. You'll be less likely to miss a negative. So there's my triangle. We said that the x value was the -5, y value was the 12. Do the Pythagorean theorem, you'll get 13. When we're doing these problems, these need to be Pythagorean triples, so you should get an integer here. If you don't, you got a mistake somewhere. Not saying that it has to be that way, but for anything that we're going to do, that'll be the case. So that's one way to kind of check, like, oh, something's not right, because that's not a quote-unquote nice number. Then you've got, unfortunately, 2 more equations that you have to remember, and you've actually did this before in chapter 5. I need to remember that the cosine of theta is equal to the square root of 1 plus the cosine of 2 theta over 2. That's a theta, not 0. And the sine of theta is equal to the square root of 1 minus the cosine of 2 theta over 2. When we wrote those in chapter 5, this was actually theta over 2, and this was theta, and there was a plus or minus in front. That's not important. It all works out the same. But I need to remember those 2 formulas. Again, section 5 has got quite a few formulas. So you've got the cotangent 2 theta formula, you've got the x equals x prime formulas and y equals y prime formulas, and you've got these 2 that you're going to need to have. So once I've got this, I can now set it up and say, okay, if I want to know what the angle theta is, I'm going to say the cosine of theta is equal to the square root of 1 plus the cosine of 2 theta. Well, that just so happens to be that triangle. So I just need the cosine of that triangle, and cosine would be adjacent over hypotenuse. So it would be plus a -5/13. Now, we're not going to go through this entire problem, but I'm just showing you what we would do. So now I have to simplify this. So I'd say, okay, cosine of theta is equal to, I know that's -5/13, so I'm going to change 1 into 13/13 so that I have a common denominator. And then when I simplify, that's going to give me 13 minus 5, or 8/13 over 2. Remember, that's technically 2 over 1, so when you multiply by the reciprocal, that 2 is in the denominator with the 13. So when I simplify this is actually 8 over 26, which I can simplify further. Now, I haven't been writing my cosine in there, so I'm going to quick squeeze that back in there. That's actually 4 over the 13. And when I have a fraction, I know I can take the square root of them separately. So I'm going to say the cosine of theta is equal to 2 over the square root of 13. And of course, your instinct is going to want to be to rationalize that, because I'm always telling you should rationalize, you should rationalize. You should always rationalize your final answer. That's nowhere near my final answer, believe it or not. I'm going to leave it unrationalized. It will be easier to deal with. And then I would go through and I would do the exact same thing. Now, I'm not going to run through and do it. I just want you to get the idea. But this is going to be the cosine of theta. So when I say that x is equal to x prime times the cosine of theta, I'm actually going to say x is equal to 2 over the square root of 13 times x prime plus whatever number I get times y prime. So then I would say, oh, the sine of theta is equal to the square root of 1 minus a -5/13. The good news is it's the same number. They both are using cosine. So one should just have a negative, one should have a positive. And then you're going to run through the steps and you're going to say, oh, the sine of theta is equal to whatever it is. I'm just making this up, 3 over the square root of 13. And then you would plug that number in here. So you don't actually know the angle of rotation. I don't really need that number unless I'm graphing it. But that's what we're going to do. Very important concept, because most of the problems you get are not going to be a 45-degree angle, or they're not going to be something that you know on the unit circle. All right, so now let's take that concept and let's apply it to the only problem that we're going to do today. And that's this one. It's going to say, sketch the graph of that equation. Now, eventually, when we get to section 3 tomorrow, we will be dealing with how do I identify what that is. If we try to use the ideas of what we've done before, like the first half of the chapter where it's, oh, there's a squared term and there's a squared term, that's a positive squared term, that's a positive squared term, and they're different numbers, it must be an ellipse. That doesn't work because that xy is kind of screwing that up. So just know that that's not going to work when you've got an xy term. If the xy term wasn't there, then yes, that would be an ellipse. But because that xy term is there, it's not. All right, so I recognize the xy term is there, so I've got to eliminate it. So step number 1, I'm going to say the cotangent of 2 theta is equal to a minus c, so 4 minus 1 over b. Of course, if you're doing this on the homework, I wouldn't need to see that. You can just tell me it's 3 over 4, but I would want to see that. So cotangent of 2 theta is equal to 3 over 4. That's not a number I know on the unit circle. Not to mention I don't have a calculator, so I can't think of it off the top of my head. So I'm going to draw a right triangle. Those are both positive. If they're both negative, of course, that simplifies to both being positive. So when I draw my triangle, and I say that this is 2 theta is the angle, my x is 3, it's the top number because that's cotangent. My y is 4, and that's a Pythagorean triple that you probably remember. It's a 3, 4, 5. So I've kind of done steps 1 for me already. That's step 1 accomplished. So now step 2, I'm going to swing over here. Step 2 is going to be write the substitutions out. So I've got to use the little formulas that we just got done doing. I'm going to say the cosine of theta is equal to the square root of 1 plus the cosine of that triangle, which is 3/5 over 2. And then I'm just going to simplify. So I'm going to do this in a few less steps than I did before to save myself some room. But I know that 1 is equal to 5/5 plus 3/5, or that's eventually going to be 8/5. And then remember, that's 2 over 1. So when I multiply by the reciprocal, it's not 16 over 5. It's actually 8 over 10. So I'd say the cosine of theta is equal to the square root of 8/10. And then I'm going to simplify that because that fraction can be simplified. It's actually 4/5. And then I'm going to take the square root of both of those separately. And the numerator number ends up being out nice. The denominator number, not so nice. And that's pretty common. They might both be nice numbers, and that's fine. Obviously, that's not going to be a problem. But the numerator number should at least be a nice number. If it's not, that's, again, a sign saying something's wrong. It's not that it can't. It's just that it won't for anything that we're doing. For this one now, I'm going to say the sine of theta is equal to, same equation, but that switches the sign. So make sure you don't screw that one up because you'll screw them both up otherwise. It would be 1 minus 3/5 over 2. And the work is going to look almost the same. This is going to be 5/5 minus 3/5, or this is now 2/5 over 2. And if I go ahead and divide by 2 or multiply by 1/2, that would actually give me 1/5 inside there. It's actually 2/10, which simplifies to 1/5. Take the square root of both separately. I'm saying the sine of theta is equal to square root of 1, which is 1 over the square root of 5. And now when I go to write out my substitutions, I'm going to say that x is equal to x prime times the cosine. So this would be 2 over the square root of 5x prime minus y prime times the sine. So it would be 1 over the square root of 5y prime. The y substitution would be sine, so 1 over the square root of 5x prime plus the cosine, which is 2 over the square root of 5y prime. So there are my 2 substitutions. There's step 2. So now on to the bigger part of this, step 3. I now get to plug both of those things into that entire equation. You can see there's a lot there. As much as you hated probably seeing that square root of 5 in that equation, you got a square root of 5 here. Works out really nice. All right, so let's go ahead and make that substitution, and then let's do our simplifying. So I have 4x squared, so that means it's 4 times that thing squared, so 2 over the square root of 5 x prime minus 1 over the square root of 5 y prime. I prefer that you keep the primes in there now. The next step we can get rid of them, and that's squared, plus 4 times x, which is 2 over the square root of 5 x prime minus 1 over the square root of 5 y prime times y, which is now this one, which would be 1 over the square root of 5 x prime plus 2 over the square root of 5 y prime. So there's 4x squared plus 4xy. Now I've got plus y squared, so plus that squared. It's 1 over the square root of 5 x prime plus 2 over the square root of 5 y prime, quantity squared, minus 2 square roots of 5 times x, which again is the top one. So 2 over the square root of 5 x prime minus 1 over the square root of 5 y prime. Next is plus, and I'm running out of room, so I'm going to spill over the next line, plus 4 square roots of 5 times y, which is the bottom one. So it's 4 square roots of 5 times the quantity, 1 over the square root of 5 x prime, plus 2 over the square root of 5 y prime. And then to finish off my equation, it's minus 30 equals 0, or I'm going to say equals 30. And then like we said yesterday, I'm just going to put a line there to separate the fact that that's all one line. And I ask that you please, please, please do your work the same way. If we all do it 30 different ways, that means I have 30 different ways to try to figure out what the heck you're doing, and it makes it really, really confusing. All right, so you might want to just take a second, double check to make sure that you've got everything. 4x squared plus 4xy plus y squared minus 2 square roots of 5 times x plus 4 square roots of 5 times y equals 30. Obviously, that sign has to be correct. All of them do. You make a mistake on one of those signs, you're not going to get the xy terms to cancel, and you're going to have, not a nightmare, but it's going to create a lot of work. So 2 things left to do. I've got to FOIL and then eventually distribute the 4. Please do them separately. I'm going to FOIL. Remember, if you like to see the 2 parentheses sitting next to each other, you can do that. When you multiply the 2 first together, it's really just squaring that number. The reason we left that unrationalized is, think if you've got this and you square it. That means that squared would be 4 times 5 divided by 25. You now have to simplify. Well, guess what? If you just square this, you just square them both and it simplifies itself right away. That's why we don't rationalize. So when I square that, it's going to give me 4/5 x squared. Remember, when you do the insides and outsides, they're the same thing, so just double it. So if I multiply these together, it's going to give me negative 2 over 5. Double it would be negative 4 over 5 xy. Squaring that, it's negative, but you're going to square it, so it becomes positive 1 over 5 y squared. Plus 4 times, these are going to have to actually get FOILed out. It's going to give me 2 over 5 x squared. If I do the outsides, I get 4 over 5 xy. If I do the insides, I get negative 1 over 5. So 4, negative 1, it's going to give me 3 over 5 xy. They're all going to have 5's in the denominator, so you can almost ignore that if you wanted to. So like I said, 4 minus 1. The numerator is going to give me negative 2 over 5 y squared. Plus, foiling that, square the first term. It's going to give me 1/5 x squared. Insides and outsides, multiply those 2 together, I get 2 over 5. Double it, it's going to give me 4 over 5 xy. Square the last term, it's going to give me 4 over 5 y squared. Minus, make sure you go slow here. You got 2 things to worry about, the radicals and the fact that that's a negative 2. The radical 5, they're going to cancel. That's 2 times negative 2, that's going to become a minus 4x. Double negative, so it's going to be plus. 5's will cancel, the square root of 5, so it's going to be plus 2y. Over here, distribute. The square roots of 5 would cancel, that's going to give me 4x, so plus 4x. If I distribute here, the square roots of 5 cancel, I get 8y equals 30. All right, not done simplifying, because I now have to distribute the 4, the 1, I guess, and then we'll combine like terms. So distribute the 4, I'm going to get 16 over 5x squared minus 16 over 5xy. Remember, everything's going to be over 5, so you're really just worried about the numerator. Plus 4 over 5y squared. Plus, if I distribute the 4, it's going to give me 8 over 5x squared plus 12 over 5xy minus, pay attention to signs, 8 over 5y squared. There's an implied 1 here, so you can basically just drop the parentheses. So it's 1/5 x squared plus 4/5 xy plus 4/5 y squared. If I go ahead and combine like terms, I see the negative 4x and the positive 4x, they actually cancel out. You don't need to put a line through them. You can just leave it like that. If you want to do it, make sure you do it lightly. Then I'm going to get plus 10y equals 30. Hey, I got that on the one line. I'm going to go ahead and just put a line underneath it just because I'm used to doing it. And now I'm going to combine like terms. So before you do anything, look at your xy terms and hope that they cancel. There's one, there's one, there's one. Remember, they all are over 5. That's why it's good to have a common denominator. Even if you could simplify these fractions, I probably wouldn't, because it'll make it easier when you go to add like terms together. Negative 16, positive 12, positive 4, yep, they do cancel. If they didn't, like we've said before, that means you've got to go back and you got to figure out what the heck went wrong. It could be because you drew your triangle wrong. It could be because you plugged in the wrong fraction here. It could be because you messed that up. If you accidentally do this, you're going to get the right numbers, but they'll be in the wrong spot. So there's a lot of little things that you got to be careful with. Got to make sure the signs are correct. And then, of course, all the algebra's got to work out. But I was saying yesterday is if this was negative 16, that was positive 12, and that was negative 4, and I say, well, wait a minute, had that been positive 4, they would have canceled. That means I probably just missed a sign somewhere. I would go up and double check it. If you're on the test and this happens, obviously you have to keep going. What I would recommend that you do is this. I would just write this note. I know they don't cancel, but I'm canceling them. That's not something you should do, but if you're in the test, you don't have time to sit there, and if you can't find it quickly, you're not going to have time to go back and redo the problem. Maybe you will, but if you don't and you say this, you can at least finish the problem off and still get the rest of the credit. All right, we're still not done. Step 3, I've got everything all multiplied out. Now the last thing I have to do is write this conic in standard form, so I'm going to go ahead and add like terms. So there's an x squared, there's an x squared, there's an x squared, and that's going to give me 16 plus 8 plus 1, 24. That's 25 over 5, or that's 5x squared. Remember we said yesterday, they tend to work out pretty nice like that. There's a y squared, there's a y squared, there's a y squared, and this one's really nice. It's 4 minus 8 and 4. They completely cancel out. So I have 5x squared plus 10y equals 30. I said they generally do work out really, really nicely. Now, if you don't get these to cancel and you end up doing something like this, they may not work out as nice, but you just have to keep going and doing what you want, or doing how you would normally do it. At this point, you're on to step 4. You should now recognize what that is, because the xy term is gone. You've got one squared term. That's a parabola. So now remember what the standard form of a parabola looks like. You want quantity squared on the left, and then you want a quantity with a number in front of it on the right. So I don't want that 5 in front of that x squared. I'm going to move the 10y over. There's a couple things I need to do. I'm going to move the 10y over, which makes it negative. And I do not want that 5 on that x squared. So you can either quote-unquote factor it out, or you can divide by it. Since those are both divisible by 5, it's probably just a better idea to divide everything by 5. All right. So now I've got it like this. Standard form, that technically is x minus 0 squared. You don't have to write it like that. You can leave it as x squared. And then remember, factor out whatever number is in front of y, even if they don't have it in common. So I factor out negative 2. That leaves me with y minus 3. There's my parabola in standard form. So now when I go to graph this, I just have to understand how to graph that. There's my normal xy coordinate system. We are going to rotate it. Now, you notice that we never actually found the angle of rotation, so it's a little bit difficult for us to do this without a calculator. I can obviously pull my calculator out, and I can find out what the angle of rotation is, and if we do that, you should end up getting 26.6 degrees. But like I said, that's not something that you would have the option to do on the test. So what I'm going to tell you to do is, you don't know what it is. I just pretend like it's always 30 degrees. I'm just going to say that this is theta. Basically, you're saying to me, I don't know what it is, or even if I could figure it out with my calculator, we're just going to get to the point and say, okay, maybe I can't tell you what it is right away because I don't have a calculator, but I can still graph the idea. If it actually is rotated more like 50 degrees, okay, so be it. Going to go ahead and put tick marks on this. And then remember, we're going to look at it as if this is my normal x-axis, that's my normal y-axis. It looks like my vertex point would be at the point 0. And then positive 3. So 0, positive 3 is right there. There's my vertex point. Then if you remember when we were looking at the first half of the chapter, the next thing that you would want is you would want to know what the... Actually, let's take that back. I was going to say you'd want to know what the focus is and do all that graph. We don't need any of that. We're just sketching a graph. That's a negative 2. So that means it either opens to the left or it opens down. Remember, x is squared. That's normal for a parabola. That means it's opening up or down. That negative means it's down. So we're just going to draw a rough sketch. We don't care about anything else. And now you turn your paper back and there you go. There's your graph. This is the graph of that equation. And you can see, had I looked at just the squared terms, I would have thought that that's a parabola. That's definitely not a parabola. We'll look at how we can identify that later. So again, you can see that a lot of algebra. Going to be a little bit more algebra than you dealt with yesterday. Same concepts. It's just dealing with the drawing the right triangle. Make sure if one of those two numbers is negative that you put it on the x value. All right. Best of luck when you try the homework. And again, like always, let me know if you're having trouble. Assignment will be on Schoology.